Right, I've got another bit of weird industrial stuff here, along similar lines to the gas analyzers. This is a paramagnetic oxygen transducer. Now, when I saw this on eBay, I thought, oh look, a paramagnetic oxygen transducer. And I thought, what the hell's one of those? So I did a little bit of Googling, and it's looks like a sort of slightly interesting bit of tech. So I thought for the princely sum of 99p plus shipping it was worth a look. I found this very helpful page on the manufacturer of the website, Servomex, that explains how this works. Quite clever. The oxygen is attracted towards magnetic field, unlike most other gases. So they generate a very powerful magnetic field. Suspend two little spheres full of nitrogen inside it, so that when the oxygen gets attracted into that gap, it displaces those and rotates, causes a rotation. We've got a mirror to provide like a mirror galvanometer type thing to detect small deflection. They then pass a current through the wire to balance it out. So the idea is that they start off by balancing the beam between the two photocells, and then the oxygen will cause those to shift because it's displacing the spheres. So that's then put inside a control loop to rebalance it, so that the current going through this wire here offsets the force created by the oxygen displacement, and by measuring that they get a measure of the oxygen concentration. Very clever. It comes in two boxes, sort of probably one's electronics and one's the actual sensor. We've got our sample in and out, and also something showing purge, which is probably just a way of just clearing the gas out. Some electrical connections here. This is in a very, very substantial aluminium casting. We've got a little keypad. It's showing 17.8, which yeah, the concentration of oxygen in the atmosphere is around the 20% mark, so that's a sort of vaguely plausible reading. If I just blow something which isn't oxygen into the port, you'll probably see it change. Might take a little bit of time. Yeah, there we go. So that's just shot right down as I've blown something that isn't oxygen into that hole, and that will probably just creep up a little bit as the air starts coming back in. And the only way I could immediately think of to make some oxygen to see if we can get a higher reading is just a simple electrolysis cell. So I've just got a container of water, a couple of stainless steel bolts as electrodes, and we're just capturing some hydrogen over there on the negative, and oxygen, and a little bit of murky gunk here on the anode. So we'll just extract a bit of that and squirt it in and see what happens. Right, so I'm just going to pour that oxygen out into this syringe. Right, so we've got a syringe full of oxygen. In theory, see what happens when we squirt it into this thing. Climbing back up towards the 18% it was before I squirted that duster in. So let's inject the oxygen, see what happens. Ooh, there we go, 47–48%, so this does appear to be working. And of course we can't let this hydrogen go to waste, so we'll have to let it do what hydrogen does. And on the top here we've got all sorts of interesting hieroglyphics, again similar to that MSA gas detector I looked at a while ago. This is designed for intrinsic safety, because it's actually designed for being used in a hydrogen-oxygen gas atmosphere, which is obviously very explosive. So the last thing you want is for your detector to actually ignite the flammable gas that you're trying to measure. So it's got the various categorizations. EXN, I think from my distant memory of these things, means that the protection is basically by means of sealing it and having a casing that's sufficiently robust that if gas gets in and ignites, the explosion's contained internally. I may be a little bit wrong on that, but it's one of the various ways of protecting stuff. So it's got BASIFA, that's the one of the approvals organisations, and also Factory Mutual, which is the US equivalent. Let's take a look inside. Nice cover that hinges over for service. It's got a nice sort of slide arrangement, so it can sort of slide up and then rest open so you can get at it, which is quite nice. And there's a little card cage with a few boards in it. Now there's a date in here of 1988, so it's quite an old bit of kit, so we're expecting to see some fairly old school electronics in this thing. So we've got some batteries down there. I don't know if that's for a real-time clock or some backup memory or something. We've got some good old fashioned analog stuff. Obviously this has been getting a bit warm. This is just some 4000 CMOS, some op amps, some precision resistors down there. Nothing hugely exciting. Again, not really a great deal on this. A load of precision resistors. Looks like they're, yeah, a lot of them are connected onto this terminal block, which goes into the main sensing chamber. Again, all pretty old LM301s, OP07s, sort of precision op amps, but very old stuff. Old school analog stuff. Another single-sided PCB. And here we've got, so I'm guessing that's probably going to be an A to D converter, analog devices, AD7555, 1987 date code. And again a few LF347s, DG509 analog switch. Nothing particularly exciting. There's a 6821, which is IO port chip. Little add-on or bodge board on the back there. This is a 2-layer board. This is obviously the main processor. What we've got on here, we've got 6802 processor, EEPROM for the code, RAM chip, 8253. Let's look up that. I think that's maybe a timer or something. 6821. So this is basically how you did microcontrollers before microcontrollers. It's like a microprocessor, external RAM, ROM, all your I/O was all external chips. So you know everything on that board will just go into a single chip nowadays very easily. This last board here. There's some ridiculously big read relays. Another 6821. These are some, I'm guessing these will be drivers. Yes, they'll just be like Darlington drivers or something driving these relay coils. So these relays just go to this terminal block. So this is providing some alarm outputs to whatever this thing is monitoring. Safety system or gas alarm or something. Put a bag down here. What's in here? Some fuses and some spare gaskets. That's nice of them. It looks like this system can have multiple devices. We've got like a chip select link, so that'll probably just select which address this board sits at. I imagine there's probably different versions of this processor for different products, so you want to keep it nice and flexible. And there's a power supply down here. I'm not going to bother taking that out. There's looks like an old-fashioned transformer-based power supply in there, so nothing really of any serious interest in this box. Just a couple of little details I noticed on these boards. One is these fuses. These look a bit weird, but these are actually potted. I think the reason for this is to do with intrinsic safety. If the fuse blows, then any hot, the hot fuse wire can't be in contact with the gas, so that encapsulation just keeps that safe if the fuse blows. Also, there are these groups of 3 Zeners connected in parallel. This is a fairly standard way of controlling the voltage that can go into any part of the system, and this being the board that connects to the actual sensor here. So these 3 Zeners ensure that even under a condition where there's 2 faults, i.e. potentially 2 Zeners gone, you've still got another Zener protecting the controlling the maximum voltage that can find its way into the hazardous area. So that's quite a common technique intrinsic safety and has this area design, it's sort of triplication of safety critical parts. I think that may also be why they've used these massive great read relays, because they're external signals. They probably want to have a reasonable current handling capability, but of course a normal relay could potentially create a spark, so they've used these potted read relays again to make sure there's no potential for spark ignition in this unit. Also in the power supply there is a solid state relay there. Don't know whether that's for turning the power onto the whole thing or not, but again, the reason they've got a solid state relay there may well be because of the safety requirement to avoid spark ignition hazards. Right, hopefully this side will be a little bit more interesting. Ooh, danger. Now that's not actually a very helpful sticker, because I mean, danger what? Is it hot? Is it explosive? Radioactive? Sharp? Who knows? Big lump of foam rubber here, which I would imagine is probably thermal insulation. Yeah, this thing looks like it's been getting a bit warm. Again, like sort of chemical oriented stuff, I'm sure this probably needs to run at a stabilised temperature for accuracy. Yeah, it looks like just a separate chamber within a chamber here. I can't easily get this foam out, but I can't really feel anything in here apart from the wires that are coming in through the other side of the something which is stuck on the side. I'm not sure if that's a heater or a sensor or what. It's just a black blob. Right, let's see who lives in here. Right, so this is where all the magic happens. We've got the two tubes coming in the side there, and these curly stainless tubes going into this chamber here. Some nicely labelled connections. Down this side you can actually see a power resistor. This, I'm sure, will be being used to heat the chamber. You need to get this thing out to take a closer look at it. Right, let's notice there's some another two heater resistors sort of on these two sides. There isn't one here, but there's this, which I would think is probably a thermal cutout switch. Just take a look. Yeah, that looks like a what's left of a thermal fuse. Of course, that will have probably been potted for the intrinsic safety requirements, so when it opens, any spark it produces is contained inside the potting. Right, so this is where all the magic stuff happens. We've got this outer magnetic frame and these two very powerful magnets which will be producing the magnetic field. And on this side we've got the oxygen inlet and outlet. That's also teed off here, as I'm sure this will be a pressure sensor. Yeah, it says 15 psi absolute on there, so that will be just measuring the pressure, which of course will be a significant factor in the measurement process. These coily bits on the tube, I'm sure that's just to decouple any stresses and just absorb vibration and stuff. And on here looks like we've got some adjustments for this part here. There's a few connections in here. This is probably going to be to do with the optics for the readout. This looks like a platinum resistant sensor for accurate temperature measurement. That also looks like a thermistor or something. I'm not quite sure why they'd have two different temperature sensors, unless maybe there's a power resistor over here. Perhaps there's some more heating for temperature control. Perhaps this controls the yeah, there's some sort of power resistors, one there and one there. Maybe that's a thermistor that controls the fine heating or something. Well, that was done up pretty tight. All the screws on this thing seem to be done up extremely tight, or they've got maybe they've sort of rusted solid, because there does seem to be quite a lot of either rust or corrosion or something on here, because it's been running, presumably because of the temperature it's been running at. Oh, that one comes out. Okay, so I think it's a case of just undo everything we can and see what happens. Right, so there we've got two photo cells, which would be the sensing elements. But they're pretty wired in inverse parallel, so it produces a positive or a negative signal if the light source isn't directly in the centre. Right, so I'm imagining this is going to be our light source, a little metal can LED, probably infrared. It's quite hard to see, but there does seem to be a mirror bouncing around in there somewhere. Let's see if we can get in from this side. These magnets are actually very powerful. It's actually quite difficult to keep the screwdriver away from them. Finally managed to get these Allen screws loose without breaking any more Allen keys. This block here looks like copper. I think it's actually brass that's got discoloured by the heat. If you look sort of down the screw head, you can start to see the brass colour in there. But there's quite a few of the, like the pneumatics fittings as well, seem to have turned into a coppery colour. I don't know if that's just the heat or the combination of heat and chemicals or whatever. So these are pretty damn powerful magnets. And we're starting to get towards the actual guts of this thing, which seems to be this chamber. There's some sort of, I think these are just probably metal shims just to concentrate the field as close in as possible. I'm sure they're either glued or soldered on, hard to tell. Glued apparently. And it looks like we've yeah, this is also magnetic, so these will be more sort of metal parts to concentrate the magnetic field. Yeah. Right, so we can now see the actual chamber. So this is our actual chamber with the mirror and the two nitrogen filled glass spheres there. And bouncing around. That's obviously a very lightweight mount for detecting very tiny amounts of force. This glass window is fairly well glued in. Obviously this thing may have to withstand a certain amount of pressure, so that's why it's all stuck together, and the glass is not going to come out in one piece. And I'm sure these metal pieces will be sort of magnetic poles designed to just focus as much magnetic field as possible in the area of those spheres to maximise the concentration of the oxygen. And so the slightest touch will get this moving, so this is clearly a very sensitive mechanical arrangement to detect just tiny amounts of force. In fact, you can possibly just about see the shape. Those magnetic poles are actually sort of triangular, so they're almost like a knife edge, just to produce a really intense field, literally between sort of here and here. Just about see the sort of 90-degree angle there. So these various bits of metal will be arranged so they conduct the magnetic field sort of from here, and probably sort of arrange it so it ends up as a vertical field between these pairs of pole pieces. So looking at it closely, this is actually just suspended on a piece of wire. Now this is all glued. I don't think there's actually going to be any chance of getting this apart any further, so I think I can probably get this out just by cutting that wire. Yep. All that massive great casting, and this is the actual active part, this tiny little glass spheres and a mirror. Like those spheres are actually held in by some sort of little wire frames. I imagine those are probably handmade by someone under a microscope at great expense. Now I'll just put this chamber back in the pole pieces, and as expected these are extremely, the field between these plates is huge. On just this thin stick of scalpel blade, it's really some effort to get it off of those. It's a very, very strong field there. So another interesting bit of obscure technical kit there, something I never knew existed before I saw it on eBay. And it's quite interesting that, yeah, unlike the other gas detectors, this is almost a purely physical process, just relying on that unusual property of oxygen. So just got to try and think of something interesting to do with these magnets now.